Problems 4, 5, and 6 are the three that are the most challenging of this mini lesson. And so I thought it might be helpful for me to sort of walk you through how I went to solve them. And so if you're totally understanding everything and you've checked in with me already, you don't necessarily need to watch this part of the video. You're welcome to move on to the practice problems. But if you were like, this feels a little confusing, I encourage you to stick around so I can talk you through how I solved these three problems. So starting with this equation or inequality here, I've got negative 4x plus 5 is greater than or equal to 25. And so remember that the first thing, once I've written an inequality, then I need to rewrite it as an equation. So it's got this step for me right here. I know I didn't give you a ton of space, so maybe I'll just rewrite this over here as negative 4x plus 5 equals 25. And so now I need to solve for my variable. And so I'm going to use my inverse operations with my goal of being isolating this x. And so to do that, I'm going to start with any constant to move that around. So I've got this positive 5 here. So the first thing I want to do is subtract 5 from both sides. And that's the additive inverse, and so that's going to disappear. And so I have negative 4x, because I just brought that straight down. 25 minus 5 is 20. And so now I think about how do I isolate this x. The math that's happening between this negative 4 and this x is multiplication, so the inverse of that is division. So I'm going to divide both sides by negative 4, and so I would say, hey, my boundary is negative 5, because 20 divided by negative 4 is 5. So I know my boundary is negative 5, and so now when they've given me actually a couple of values here that are on either side of the boundary. And so if I want to then sort of plug those ones in, I've got 0 and 7, which are both greater than. These two here would be, I could write that as x is greater than or equal to negative 5, because both 0 and 7 are greater than. And then x is negative 7. This would be an example of something that is less than negative 5. So starting with, let's try 0. So what that says is I need to check via substitution. So I can plug in 0 for wherever I see x in this equation. And so that would be negative 4 times 0 plus 5. And I want to know, is that greater than or equal to 25? So 4 times 0 is 0 plus 5. 0 plus 5 is 5. 5 is most certainly not greater than 25. That does not work. So we know that 0 doesn't work, which tells us then that 7 does not work. And so x cannot be greater than or equal to 5. It has to be this one. And so we can prove that by checking it. We can substitute negative 7 in to our original equation. So I'd write that as negative 7 times, negative 4 times negative 7 plus 5, is that greater than or equal to 25? And so now I think negative 4 and negative 7 multiplied together is positive 28 plus 5. And is that greater than 25? 28 plus 5, well, that's going to be 32. So 32 is greater than or equal to, absolutely. So that works. So we knew that that was our original prediction, but we've just proved our answers right here. So when I go to graph this, so now I know that my solution has to be x is less than or equal to negative 5. So on this number line, I think I've got 10 spots in here. Since I know it's going to be less than negative 5, I'm not going to, normally I start by figuring out like the midpoint and putting maybe 0 there. But since I know that it's already going to be less than that, maybe I'll put 0 over here, because we don't actually care about any of these numbers up here, because we know that, oops, I don't need to write 4 twice. X has to be less than that negative 5 right there. So I could maybe draw my number line something like this, that since this is less than or equal to, I can put a solid dot and then my arrow continuing this direction like that. For number 5 and 6, the one thing I do want you to remember is that even as we go to either distribute or divide things through, you might not get whole numbers, and that is okay. And so if I think about if I'm facing, my typical strategies, can I get rid of decimals? Can I get rid of fractions? Can I do powers of 10? And with this one, I can't really, I'm like 17.4 doesn't evenly divide by 3, but I can't also, like distributing doesn't really do either, doesn't help me really either. So I'm just going to do what feels natural. For me, that's distributing. So I'm going to distribute that 3 in. So I could rewrite this as 3x plus 12, because 3 times x is 3x, and 3 times 4 is 12. And then that's going to be, I'm going to rewrite this as an equation right now, 17.4. So now I can use my inverse operations to isolate that variable. And so the first thing I want to do is get rid of that 12. The additive inverse makes that disappear. So now I have 3x equals 17.0 minus, or 17.4 minus 12.0 is going to be 5.4. If I don't know what that is off the top of my head, I'm going to calculator that for sure. And so I'm going to get 3, or x is equal to negative 1.8. And so again, for when I go to graph this to figure out which way do I need to shade, because this is in like this 1.8, I'm trying to figure out like where on here 1.8 should be. Maybe I put it like right in the middle. And so I'll say 1.8 is my boundary, and maybe I'll go up by increments of 2. And so this would be 1. Is this going to be positive? Oh yeah, this is, I'm going to go 1.6, 1.4, 1.2, 1.0, 2.2, 2.4, 2.6. So I know that this is my boundary, and so since this is a greater than, my dot here will be 0. And in order to figure out which way I need to draw my line, again, I can choose a value that is on either side of that number, that boundary, and figure out if it works. And so maybe I'll choose 2 because it's easy mental math for me to do. And so I can think 3 times 2 plus 12. Is that going to be greater than 17.4? 3 times 2 is 6 plus 12, so that's 18. That's absolutely greater than 17.4. So that tells me I need to draw my arrow that way. So I like that method when I'm faced with kind of inconvenient numbers, is just to place your boundary on the number line first, and then choose a number that's on either side of it, and that tells you which way to draw. And so 6 is a very similar situation as number 5. You're going to end up with some incorrect or some sort of awkward numbers as well.